Kirsten is from Shopify, and she's going to present about deconstructing the monolith, designing software that maximizes developer productivity. You can follow her at KMK, Westeinde, which is her second name.
Don't worry.
And she knows how to pronounce it. So, Kirsten is a technology enthusiast and lifelong learner. She's a senior software engineer at Shopify, where she solves challenging development problems every day. She has worked with Ruby on Rails for 5 years plus, and is constantly adding new tools to our technology tool belt. She's passionate about building diverse teams and gaining new perspective through travel and cross-cultural communications. When she's not working, you will most likely find her out exploring in nature. Kirsten. So welcome, Kirsten, once more.
Okay, cool. Yeah, I just want to start with a huge caveat, which is that I'm a huge procrastinator, and I was planning on finishing this talk and practicing it yesterday, but my computer was stolen, so it's not going to be as smooth as I had hoped, but we're still going to do it. Yeah, so as he mentioned, I work at Shopify. We are one of the largest Ruby on Rails applications running. We've been involved in the development of Rails since the very beginning. We contribute a lot to open source and also entrepreneurship. Our customers are entrepreneurs, and our goal is to make it more accessible and easy to be able to start a business. And we try and use our economies of scale, basically, to get smaller merchants access to the same features as these massive brands would have. We also have a different type of entrepreneurs, which are our Shopify partners. So these are people who either build commerce stores for their clients, or develop apps on our system, or develop themes. And I think I've spoken to a couple of you who actually develop on Shopify, which is awesome. There's a lot of opportunity there. So yeah, I'm going to be talking about deconstructing the monolith, designing software that maximizes developer productivity. So we got a really great introduction into kind of what monoliths are and one possible solution yesterday by Yatish. So I'm going to keep digging into this topic. Shopify is now a public company, and so my PR team would not allow me to share all of the stats that we got to hear yesterday. But let's just say it is massive and operating at a really, really, really large scale. And it also has a ton of functionality that, for now, a lot of it is living in the same code base. So, so specifically the Shopify core, which is what we call the code that actually runs the Shopify platform, so the core functionalities like orders and checkout and all that, that lives in a code base called Shopify core. And that is a monolith, but we also build a lot of other services, and each team basically has the freedom to choose how they want to build it. So you'll find examples on all ends of the spectrum, from whether it's microservices to small apps with just one responsibility, to these kind of larger monoliths. And I've been with the company for almost 4 years, and I've actually worked on pretty much all ends of the system. I've worked in Shopify core, and then I actually worked on a project that was extracting a piece of functionality that historically lived in core out into its own service. And now I'm working on a project that is made up of about 10 independently deployed microservices. So just first to kind of put into perspective what I'm talking about. Microservices occur when there's a high number of deployment units, but also a high amount of modularity. So that means clearly defined boundaries between each service. So you can deploy a bunch of things and think that you're doing microservices, but if the boundaries are not enforced, then you just have a distributed big ball of mud. And similarly, the bottom left corner is kind of what we talk about when we say monoliths. All the code lives in one place, but there's also no boundaries between them. Whereas you can have a modular monolith, which is like what I'm calling it here, where there are well-defined boundaries between the services, but it still lives in one place. So yeah, I want to just use our time together today to go over, in a bit more depth, the definitions, and then analyze the pros and cons. These are just like from my brain, so I'm sure there's other pros and cons as well. And then I'm going to introduce a third option, and it's actually a different option than what was discussed yesterday. So there are different solutions depending on what your problems are. But I think this one is pretty interesting. And then I'm going to try and conclude by saying, like, is there a right choice? I will tell you right off the bat, there is no like one-size-fits-all right choice. I think there might be a right choice like dependent on a bunch of factors. So hopefully we'll be able to answer some of the questions that you can ask yourself to figure it out. So a monolith explicitly means that not only is everything living in one code base, but there's a bunch of different functionality in that same code base with no boundaries between them. So if you have an app that does like one or two things, just because all the code lives in the same code base does not mean that it's a monolith. It only becomes a monolith when there's a ton of different things happening and there's this like spaghetti entanglement between all of them. So for example, at some point in the not so distant past, Shopify was responsible for billing merchants, customer checkout, managing orders, managing developers' apps, shipping, updating products, and much, much more. So these are clearly distinct functionalities, and they were all in the same place, so this is why Shopify fell into the category of being a monolith. And as PJ mentioned yesterday, Rails itself is a monolith, so it kind of lends itself to building monolithic apps if you just use it out of the box and don't think about these things. And that's kind of what we did, and that's why we ended up here. So microservices are a suite of independently deployable, small, modular services in which each service runs a unique process and communicates through a well-defined, lightweight mechanism to serve a business goal. So each of those boxes is actually like deployed somewhere separately, and then the lines between them is communication over the network. Okay, so let's talk about the pros and cons of monoliths. They're not all bad. Firstly, the code is all in one place, and this is nice for a couple reasons. One, you only have to maintain one repository, you only have to search through one code base when you're looking for things, and you also only have to deploy one thing, which leads into some of the other things. So yeah, there's only one test and deployment pipeline. Depending on the complexity and scale of your app, these pipelines can get kind of confusing or complex, I guess I should say. And if you're customizing them, then you're going to have to be orchestrating that the same customization is happening across all the different places. Whereas when you just have one, you can just do it in one place and trust that it will work. Yeah, so all the data is available everywhere. That's because it's one app, so there's just one database. And so when you need the data, you can just ask the database to give it to you. And yeah, having to maintain one infrastructure is like a pretty similar argument to the test and deployment pipeline. Most Ruby applications will have like at minimum a database, a web server, maybe background jobs, maybe Elasticsearch, maybe Kafka, maybe Redis. And so that's already a lot of complexity for one app, and every additional service you add just like doubles and then triples that. So for like right now, I'm working on a service that has, or like microservices that are 10 independently deployed things, and I have to spend much more of my time than I would like doing DevOps things. Whereas if you only have one infrastructure, you can focus a lot more of your time on actually building. And it also, having multiple infrastructures, this is very topical to the last talk, but it really, like, it's a lot less resilient because there's a lot more points of failure, and you have to worry more about the things that were just talked about, where if one goes down, how does it impact all of the other ones? Okay, so the cons. Yeah, slow tests. This just comes from that like entanglement that we saw. Everything being interrelated, it can really cause them to slow down. Similarly, new code having unexpected repercussions. If you change something, for example, in shipping, it should not break something in order creation. And yet, if you don't have boundaries between the two, it's very likely that it could. And then you need to understand the entire code base. So this was mentioned yesterday, but for example, if our shipping team hired a new developer, they should just be able to understand the shipping code to be able to be effective in it. But that's actually not the case. They have to understand everything, how orders are created, maybe how payment is processed, because it's so intertwined. And that can really slow down the onboarding experience. So it might seem like the pros and cons are balanced. There's actually fewer cons, so maybe monoliths are great. Well, there's going to come a time, depending, like when you reach a certain scale, that the cons just like fully outweigh the pros and just are really, really slowing down your ability to develop new features. Again, recently in Shopify's history, there was a time when no one would even bother to run the test locally because it would take forever. It was just not possible. And that's obviously a very not great place to be. And then often when we'd introduce new changes, everything would break, and we would spend hours, even developers who knew the code well, just trying to figure out, like, following the trail of entanglement. And then, yeah, new developers were having a hard time onboarding. So all of these things were kind of like the tripwires that told us this solution was not working for us anymore, and we needed to find a better one. Okay, so what about microservices? Each service is lightweight and has one clear responsibility. So it makes each individual service very easy to understand and easy to maintain. Yeah, individuals or teams can work on separate services, and this is really good if a team has maybe different timelines or different product requirements, or even they want to use different technologies. They're completely free to do that and can work independently without affecting the other services, so long as the API between them does not change. This is kind of similar to the first one, but each individual system is easily understandable, and theoretically, if you have a different team working on a different system, then they only need to understand one system, and it's a lot easier. So, like in the example that I gave earlier, if shipping had been a separate system and they hired a new developer, the time for them to be able to be effective would be a lot less. And services can scale independently, and this is cool because not all services have the same like resource requirements. For example, like we have to process payments on every single checkout, but we don't necessarily have to ship every single order. Like Shopify only does shipping for merchants who have opted in on it. So the shipping service could be deployed with many fewer resources than, say, the payment processing service. I also thought of another new pro yesterday that I haven't added, but you could theoretically open source individual microservices if they're separated out in a way that you would never be able to do if it was all in a monolith. So all of the cons are essentially the inverse of what we talked about for monoliths. Many different test and deployment pipelines, infrastructural overhead for each service. Because they're deployed in different places, network communication is needed between them. And if you have 2 services, perhaps that's not a problem. But if you're getting up to the point of 10 or 15 services and you're communicating with a request response pattern, you could see how this would really, really slow down your system. Yeah, the data not always being available where you need it. This one is kind of dependent on how you choose to implement it. But likely what will end up happening is that each microservice will have its own database, and it won't be able to just reach into the database of another one. It will have to ask for data as needed. So large refactors can be super annoying. On the project that I'm working on, we have a gem that has all of the shared code for all of the different services, just so that we're not duplicating it over 10 services. But every time we change any code in there, that means we have to update gems in 10 different services. So 10 different PRs, 10 different deploys. And that's just like a small example. because sometimes refactors will be interdependent, and then not only do you have to do multiple PRs, but you have to orchestrate the deploy in such a way that they all go out either in the right order or are able to handle both the old and the new version. So I found this paper. It's written in 1971, which I think is funny, but it's very topical still today, so I'm just going to read it. It says the expected benefits of modular programming fall into 3 classes. First is managerial, so development time could be shortened because separate groups would work on each module with little need for communication and little regret afterwards that there had not been more communication. The second is product flexibility. It was hoped that it would be possible to make quite drastic changes or improvements in one module without changing others. And the last is comprehensibility. It was hoped that the system could be studied a module at a time with the result that the whole system could be better designed because it was better understood. So I think that just does a much better way of saying what I was trying to say with my pros and cons lists. But I do really think that it's interesting. 2 things. One, that it was written in 1971, so clearly this is not a new idea, but it's something that has become a lot more topical and kind of trendy recently. But secondly, there's no actual references to microservices. The word that is being used is modularity. So, is there a happy medium? If we think back to the pros and cons list, all of the pros in monoliths came from the code living and being deployed to the same place. Meanwhile, all of the cons of microservices came from the code living and being deployed to separate places. But all the pros of microservices came from the fact that there was strict boundaries between the different responsibilities. And conversely, the cons of monoliths came from the lack of boundaries. So is there a way that we can get the benefits of strict boundaries at the same time as getting the benefits of everything being in one place? And that is where the idea of a modular monolith comes in. So this is where the code is all living in the same place, but there are boundaries and they're strictly enforced between different domains. So I'm going to get into implementation details in a couple of slides, but for now I just want to think about this idea conceptually. So if you already have a monolith and you've decided that you want to go to microservices, this is probably going to be the first step in your journey anyways, because you'll only be able to extract services once the boundaries are cleanly defined between it and everything else. So maybe it's a step on the way to microservices, or maybe you'll find that it is good enough and it can be kind of your resting place. So I want to circle back to the pros and cons of monoliths and microservices and see how they carry over to modular monoliths. So we're able to get rid of most of the cons while keeping most of the pros. The one that we have lost is all data being available everywhere, and this is dependent. Because all the code lives in one place, you could theoretically just have one database and let everyone access it, but that's kind of defeating the purpose of having strictly defined boundaries. So I would suggest, at least, especially if it's on your way to becoming microservices, that you like partition the database and enforce the boundaries between them. Okay, and then what about microservices? So here are the pros and cons again. And modular monoliths got rid of, again, most of the cons and kept most of the pros. The only change we had to make was changing the word services to modules. The con that we have kept is data not always being available where you need it. We kind of already talked about this. Maybe it's not so much of a con because we do want those strictly defined boundaries. And then we also lost the ability for services to scale independently because we're deploying it all in one place, so we just kind of have to give it the maximum amount of resources that the whole system needs. And I hope it's clear why the other pros and cons have stayed. Okay, so how do we achieve this? I'm going to talk about the implementation details, assuming that we already have a monolith, because that is a situation that Shopify found itself in when we started looking into these ideas. The first step is namespacing. So you have to define and name the various domains that each module will encapsulate. And then you want to move all of the code relating to that domain into a top-level folder named after it. So this might sound super straightforward, but it's actually way harder than it sounds, and one of the steps that was the hardest for us. You might have heard the saying that there's two hard things in computer science, naming and cache invalidation, and it is very, very true. And also just figuring out where the boundaries lie in a system that has been so interdependent for so long. But luckily, going into this, you already have much more domain knowledge than you would have if you did it from the get-go, so you should have at least a sense of what the various domains that are happening in your code base are. And then the second step is untangling, which is also very tricky and painful, especially depending on where you're starting from. But this is the process through which you minimize dependencies across these services, and then you ensure they communicate across boundaries through clearly defined APIs. This step is the step that we are still in at Shopify, and we're like 2 years into this effort. So it is by no means going to be easy, but it is very, very worthwhile because we've already seen so many huge benefits. And then at this point, all you have to do is enforce the boundaries between the modules. And this is actually a really important step because right now, everyone on our team is aware, like, this is what we're doing. We're making these different domains, and we're not going to communicate across them. But 10 years down the line, perhaps, developers aren't going to know about these efforts, and unless it's actually enforced, they're going to take the path of least resistance and just reach across and ask for what they want. So you have a couple options of how to enforce these, but it has to be done in the code, so either raising runtime errors or having tests fail when the boundaries are violated. And if you are starting from scratch, lucky you, you can just basically skip step 2 and just start by namespacing and then immediately enforce the boundaries between modules. And this will give you a lot greater flexibility as you go down the line. So I want to explore the implementation details that are presented in this blog post. I'm going to go not into as much detail as there is in the blog post, so I would highly suggest reading it, especially if you are a Rails developer. It's really good. At Shopify, we are currently undergoing these efforts, but the implementation that we chose is not 100% the same as what was chosen here. And it doesn't really matter. Like, you can do it however you want as long as the boundaries are strictly enforced in the code. So this is specific to Rails, but it could really apply to any Ruby project. And I think it sounds like a lot of us here are familiar with Rails anyway. So traditionally, Rails apps are organized by technical layer, so models, controllers, views, etc. And then everything is thrown in there together. But it's much nicer, especially for ramping up new people, if we organize the code based on the domain. So in the diagram on the left, that is what you would get if you just did Rails new, and then within app, obviously there'd be models, views, controllers, etc. Whereas here, the top level folders are named after what they do. So say shipping, payments, whatever else. And then within each folder, then there is the Rails new folder structure. So then all of the models relating to that domain will live underneath it. And in this case, each of these services can either be a gem, which just uses pure Ruby code, or an engine, which uses Rails as well. So in the blog post, he talks about how they use Bundler to load engines and gems. And then they do so by looping over all of the directories. And this is actually happening in the gem file. So using Bundler is really nice and provides one benefit that I will talk about later. But it is important to note that you could theoretically define each of these gems and engines as like separate gems hosted on Ruby gems, or even just private gems, and include them all in one place. But the nice thing about having them all in one place is that you can make changes across multiple gems or engines at the same time, so you can worry less about backwards compatibility. It's basically like using a mono repo for those of you that are familiar with what that is. Okay, so then each service will define its dependencies, meaning what other gems or engines that it needs to know about. And it will do this in its gem spec. And it's the exact same place that it's going to also define external gems that it has dependencies on. So having these explicitly defined allows us to build up this dependency graph. And this is hugely, hugely helpful, even just conceptually, to be able to look at a picture of how your app, how the various domains are dependent on the other ones. So let's assume this is our dependency graph. So what this tells us is that service A doesn't need to know about any of the other services. It only executes code that is defined within itself. Service B does depend on code that is defined in service A, but it doesn't care about service C or service D. And like similarly, C needs to know about A, and D needs to know about both C and A. Conceptually, this seems great, but there's nothing that's actually stopping service C from using the code in service B if it wants to, because this is a Rails application, and in Ruby, everything is like globally accessible, so we need to figure out a way to enforce this. Even for talented engineers, unless it is enforced, it's easy to inadvertently write code that breaks this. So what we need are boundaries. In the blog post that I mentioned, Dan tells us how his team enforces these boundaries using tests. I like this suggestion as it is pretty simple to implement, and it gets the job done without having to do anything funky with how the code is being loaded. So I mentioned before that each service defines its dependencies. This is done in the gem file through an environment variable that defines which services to load. So when the test suites for the individual services are run, we actually go down into the directory containing the code for that service, and we run the tests there. And what will happen is, since the environment variable is set there, say it says to include another service, it will include that code. But if it won't include all of the other services, so if code is executed that is trying to reach them, it'll raise an error because that code is not defined as far as this service is aware. Another benefit of this enforcement approach is that it allows us to speed up the builds. We only have to run the tests on the services whose code changed or who are dependent on a service whose code changed. Since we are confident that, for example, service C can't access code in service B, there's no way that changing code in service B could break service C. So there's no point of running the tests in service C when we change the code in service B. And the way that this is done is it uses Git to figure out which services have changed, essentially, and marks them as dirty. And then it looks at what services are dependent on it and will mark those as well, and then just run the test for those. And it's nice because this will allow you to get your PRs green faster and like really speed up the development cadence. But at the end of the day, you can still run the entire test suite on master and deployment branches to be safe. And by using bundler to define our dependencies, we enforce that there are no circular dependencies because it will error out if there are. A lot of the worst architecture in monoliths comes from circular dependencies. One of the nice things that we all like a lot about Ruby is how loose and free it is, but this is one way that it can bite us. Because classes are loaded at runtime and dependencies don't need to be declared, there will often be circular dependencies and we will have no idea. So if bundler does detect a circular dependency, how to fix it is kind of up to you, and it's also dependent on the situation. It might be that the dependency is not needed and you can just remove some of the code or ask someone else for the data you need. But some of the cases are trickier, and in that case, you can look into the publish-subscribe communication pattern to kind of decouple services. So essentially what that does is one service would emit an event with all the data needed by another service, and that other service would use that data to do whatever it needs. So now that other service is only dependent on the first one, but the first one is not dependent on the downstream one. I'm going to talk about this in more detail in a couple of slides. Okay, so for now, everything is modularized. It lives in the same code base, but hopefully it's clear to see how you could, if you wanted to, extract each of these modules out into an independently deployed service. This will be especially true if you partitioned the database, like I mentioned earlier, and enforced who can access the data. So if you want to extract out a service, you should be able to just ETL the data specific to that service that you need into another service that you are deploying, and then cleanly remove the old partition from the monolith. Since the boundaries and communication across them are so well defined, then you should just be able to change the communication to be pointing somewhere else. And this is, if you're using something like Kafka to use the publish subscribe pattern, then you might actually not even need to change the communication. So extracting services out of monoliths that have not been modularized are extremely painful. One of the projects that I worked on recently did exactly that, and it sucked. Like, every time we would try and delete something, it would break a ton of other tests, and even like engineers who had been working in this code base for years would just be like spending hours trying to figure out what was happening. And like, unfortunately, due to the product demands, we had to do it at the time. But if I would do it over again, I would definitely try to modularize things first before extracting. Okay, so then theoretically, we've extracted these all out into microservices at this point. So now the lines between them are no longer just method calls, but network communication. And we talked about how that can get slowed down. So I want to examine the publish subscribe pattern a little bit more. So using event-driven architecture is when you drive communication between services, and it enables near real-time processing. So it basically means that there's no request-response pattern, but there's just emitting of events and downstream services listening to the events and doing whatever they need to. It's commonly used for microservices, but you could apply it to modular monoliths as well, especially if you're having issues getting rid of these circular dependencies. It describes activities as a series of events. So for example, a checkout could emit an event. And it might be that some services don't care about it and they can just not listen to that event. But those that do care about it, the event will contain all of the data that they need. Okay, so this is just showing the difference between request-driven architecture and event-driven. So request is where it's like communicating over HTTP. It's saying, please do something for me, and then please give me the answer, and I will wait for the answer until I do the next thing. So you can see here like how this quickly gets out of hand. The first one, it has to wait for it to come back. The second one, it has to wait for it then to go to the third one and back, fourth one and back, et cetera, et cetera, et cetera. So this can like really add up. Whereas here, when the first process is done, it just emits an event, and only the ones that care about it will do something, and they can all do the thing at the same time. So it's like essentially parallelizing the processing, which can really speed things up. So, am I saying that everyone should abandon their monoliths and microservices and go straight to modular monoliths? They sound pretty sweet. Well, no, I don't think so. I think the correct solution depends on the scale of your app and how many people are working on it, how much functionality there is, et cetera. So I kind of think of these three solutions as like a timeline that you'll evolve through as your scale and complexity grows. If your app only does one thing in the beginning, and the most important thing to you is getting it out to market and getting users' feedback, then use a monolith. Like, it will be good enough, and it was good enough for us for many years. But each of these different options are going to be delineated by periods of pain and suffering, and that's how you know that it is time to move on. So I would definitely advise against optimizing prematurely, and only going when you start to see some of those cons that we talked about. And then once you're feeling the pains from the monolith, you go to the modular monolith, and that is probably great for a long time. But as your team size grows, it can be convenient to have individual teams being able to work on their own services for the reasons that I mentioned. Like, one team might want to work in Go, the other one might want to do Rails. And they should be able to if those solutions make more sense. And so that's probably around the time that microservices will become good for you. And really, at that point, they're probably not microservices, they're really more just services. My team made the leap to microservices way, way, way too early. I joined the team and there was 2 engineers on it, and we were managing 10 services. And it was very annoying. There was a lot of infrastructure overhead. It just was not necessary because each microservice barely, like, they were so light that having them all in one place would not really have been that harmful. So I would really suggest waiting until it is right time for you and only going to microservices then. I really like this diagram. He's actually talking about like class size. So designing, like basically using object-oriented design, but I think this can apply to a lot of things. It's basically saying that in the beginning, you will be able to move faster if you don't worry too much about design and all of these things. So that's where I'm talking about just like using a monolith, getting your app to market. But then eventually, having no design will start to slow you down, and you won't be able to add functionality as fast. So it's really hard to figure out exactly where that crossover is. It's not like a nice like light bulb goes off and is like, it's time. You kind of have to figure it out. But you'll know that it's time when you are having like more and more of a hard time adding new functionality. And that's when you want to start considering design, whatever it is, whether it's modularity or microservices or whatever. But doing it before will actually slow you down. So I want to give a word of caution here, really drill this point home. I think microservices are entering the mainstream and becoming super trendy. I know like daily I have recruiters reach out to me being like, we're breaking up our monolith into microservices, and are super excited. And I'm like, I don't want to be involved with that. According to a survey in 2017, over 80% of organizations are either using or investigating microservices. So they can be an extremely powerful tool to increase agility in an organization when applied in the correct scenario. But they can also result in hugely overcomplicated systems that are challenging to maintain, like the one that I am currently on. We're actually rebuilding it at this point to make it a monolith. So, but there is sometimes that it's the right time, and that's where like the project that I worked on last that I talked about comes in. We were a team of like 10 to 15 engineers working on this project full time. We needed to move quicker than we were able to by being in the Shopify core monolith. So it was the right time for us to extract out a service. So it's kind of a judgment call, but just try and take some of these things into consideration when you're deciding. That is all. I hope that I have helped clarify how to identify which architecture to use based on your situation. Since it is so specific to individual situations, if anyone has any like specific questions afterwards.